Cool. 390, elimination game. There is a list of sorted integers from 1 to n. Starting from left to right, remove the first number and every other number until you reach the end of the list. Repeat, repeat the previous step again, but this time from right to left. Remove the rightmost number and every other number from the remaining numbers. You can keep the steps again, alternating left to right and right to left until a single number remains. Find the last number that remains on the list of length n. Okay. I feel like there's a trying to think a little bit because I feel like there's some. Well, what is n? I wish they tell you n, then maybe it's slightly easier though. I imagine it's not the n square algorithm. No, it's not even n squared. It's n log n, right? Like if you just simulate this, then it'll be n log n because you only have log n steps. Is that fast enough? What is n? I think that's my question then. N log n is fast for n instead of like less than even, I don't know, like 100,000 something, right? Um, hmm. So you moved all the odd numbers and you move all the power of twos for whatever reason. Is that true? I think right now, I mean, I definitely could write the brute force. I don't know if it's fast enough anyway, but just try to see if I could think about a cuter way. Let's say there's a 10 in there. Then 10, you would remove 10, 6, 2 instead of 4 and 8. So the parity is a little different. Um, so we could do the math. So you don't have to necessarily look backwards. You just do the parity based on the number of array elements on the second row, whether it eliminates the first element. But does that get us anything? I mean, this is unlock n, so is it really necessary to do more than simulation? I wish there's a little bit of I wish they just give you the bounds. I guess that's my answer. But is there anything cleverer that we could do? This is 6. All right. Maybe I'll. So you definitely don't have any odd numbers. And then okay, so I mean, you could think about it as I think you could do it bitwise on this one actually. So you could do it in log n, maybe. Don't hold me to that one yet. So okay. So first of all, we remove all the bits, all the possible numbers where the rightmost number is 0. Oh, sorry, the rightmost digit is 1, which means it's another way of saying if it's odd. Um, so okay, last let's see, go to n, and then I'm just writing. I don't think this is the what I'm doing, but I'm just kind of writing my dots out in code form. Uh, and then if there are odd numbers of numbers left, if there are odd numbers of number left, then we actually remove the last bit. And if there's even number of numbers left, we remove every second number, which is so then the second bit has to be 0. It's probably the wait. What is it? Then the third one, you remove that again. But the last bit is the okay. I think the second row is the one that is a little tricky for me. Because what I said was not true. So, all right, you have all even numbers. So you have, is it 10? So you have that. Is there a easy bitwise thing to figure out? Well, just that the second digit has to be 1. Is that good enough? Is that going to be true? What's 10? If that's 10. But if that stayed, then we would have eliminate all the ones where the okay. Okay, I think I have some idea, but I feel like I'm not sure. Okay, so that's if we eliminate all the odds. So we divide everything by 2. So just 1, 2, 3, 4, really. Except for now, we have to decide whether we skip the first one or not skip the first one. We have 1. So, okay, if it's even number left, then the last digit has to be 0. Okay, so then that means you have 1, 2. And then now you move that again, so you have 1. Okay. I think I have the idea. I don't know if I could explain it very well. But then if this is 5, then you have 101, but because it's odd, you remove all the 1s. So you know that the second digit has to be then the second digit has to be 1. If this is the case, then the second digit has to be 0. No? Wait, what? No, then the second digit has to be 1. No. But if 5 is here, then the second digit has to be 0. Okay. So, okay, I think I have some idea. Yeah. I'm going to play around with it a little bit first. But okay, so well, that's it. Oh, and it's bigger than 0. Okay, so if digit is even, then we just take away all the ones with odd. So then that means the last digit is 0. Okay, so then we don't do anything really. We just go to the next digit. Okay, fine. Not very good. Have to do more stuff, but do nothing for now for parsing. Else, else it is in one of the odd rounds, or even number of rounds where you go backwards, and then now it matters where. Let's call this round actually, just so that I don't confuse myself, because confusion is hard. Otherwise, it's because of the mathematical round function. Okay. So backwards, if I guess otherwise, I guess we do this anyway here. Always going to do that. Otherwise, if n divided by 2 is even. If it's even, then the last digit is also a 0. Did I forget? Oh man. So 1, 2, 5. No. Then it's a 1. This is such a mess. Okay, so if it's a 1, then current. Well, what's going to happen on that digit? Otherwise, nothing happens again. So is that good enough? Really? Let me play around with it. I'll print some stuff out. Not confident about it, but okay. Because we want a 1 in the 1 digit if and only if. I think I don't take the case where there's only one number left. So let's see. Maybe. What an annoying problem. There's nothing interesting about it, I think. Like nothing algorithmically interesting. It's just a lot of checking my cases. But it's what it is. It's just like I feel like this like weird, like I might not present certain things in the right way, but other than that, okay, let's do just no 9 is a good case though. I feel like okay. So first, so the last digit has to be 0. Last binary digit has to be 0. This means the second to last digit has to be I don't even know what I'm saying anymore. Has to be 1. And then the last digit has to be 0 again. No, the last digit has to, yeah, it has to be 0. Maybe I missed it a little bit. Okay, so because this is the case, and we want to keep the 1, so last digit is 1. Okay, and now we go to the third digit where it is 0. I mean, 0 and 0, 1, so it's 1 and so that actually you get 0 and 1. I think I messed up that one. But then you eliminate all the odd ones. Wait. But the odd ones aren't the last digit anymore, so you maybe have to do some another coin flip thing. Maybe that's why I got confused. The third digit. I guess you just, is that right? Because this will always be alternating, so maybe you have to keep track of the first. And then it keeps the 1 because it is the first number, even though that's odd, but then odd is not it's not technically odd anymore. It's just that the third digit is starts with 0, but oh man, there's just more stuff to keep track of. I know how to do that. How is this a medium? Maybe that's maybe there's an easier explanation, and I'm just like doing it silly. Or you just brute force. If the answer is brute force, can someone just tell me that it's just brute force, and I've been like wasting all this time for no reason? But Uh, hmm. How do I know this is still in a set? There are two numbers left in the third one. How do I know that the first digit is 0 instead of 1? Because it's based off the last one. Then you just because is it? Sorry, I'm not articulating that much for this project problem because there's a lot of just me thinking about it. It's just not much to articulate. It's just uh, how do I know that this is still in then? That it could be 0 and 1, but that the first digit is 0 instead of 1. Because if we do 2, if this is 10 and we have 5 numbers, then what happens? Then we have 10 and 100 left, which I guess in that case, which means in this case you have 4 and 8, even though this is divided by 4 already, so 4 and an 8, and it eliminates the first one, but in this case, the last digit would be 1 and not 0, so I feel like that the problem is also like I feel like I'm just gonna end up like guessing it and seeing if it works. I think that's why I don't like this problem at all. Uh, unless there's a pretty intuitive way that I'm just not thinking about it, but uh, so the third step, you always remove the first one, but how do we know what's in it? Well, okay, because if the last one is an odd number, then you would have already eliminated the 0, so there's like some kind of mathematical induction thing that I'm not like doing it right. Yeah, yeah. I mean, it definitely is a log n thing, but half them have to be in powers of, or like yeah, it has to be in powers of 2, which is why we have some log n thing. But it matters whether you're taking the first one or not. Sorry, I don't know if I'm articulating it well at all, but yeah, there's definitely some parity thing that I feel like I have to kind of keep track of. Uh, a weird thing. Weird. Oh, okay. Well, this is another number, but that doesn't even make sense. That doesn't make no sense. So what does this mean? In the first row, you want the digit 0, and in the second row, maybe third row. Is there a fourth row? Why is there a fourth row? No, no, I think it should be 1. But maybe that just gives you the wrong one anyway. Yeah. Yeah, but I think the tricky thing is that like if you look at n is equal to 10, then you actually get something completely different. Uh, yeah, I mean that's what I'm trying to do. It's just that it's very annoying to get it right. I mean that's essentially what I do with the mod 2 here. Yeah, but in some like order to kind of, I don't know. Three lines should be right, but oh, is it? Yeah, maybe I should have brute forced it a little bit in the sense that I should have looked at more example. But hmm. But I mean, have, I have some sort of that idea. I just don't know how to get it quite right. Okay, why doesn't this? Why is this not true? Mm, this digit has to be 0. Come on. Well, you eliminate the 0, so what are my states? Oh, well, I guess I did it after I print out stuff. Okay, so round 1 you have 9, and round 2 you have 4. Knowing that the first or the second digit is going to be a 1, but then why is my third row not counting right? Because yeah, maybe this is not the case anymore actually. Because I only assumed that flip, maybe you flip again. Some like weird. Well, maybe another way to think about it is whether the first number has a 0 or 1, and then you eliminate all the ones that are the same as the first number. So, okay, first number definitely has a 1. And then you remove all of them. Okay. And then the second one, start this. Oh, in this case, actually, it should be that. And so now the first number is that even right? Sorry. And then the second row, well, you know that the first number has a 1, and we don't eliminate it. I think there's some like state logic thing that they can. So the first row will always have It's just does the first row or the first column always have a 1? No, because in this case there's a 0, but only because we didn't eliminate it. So if last one we and I need to use the bathroom. So we eliminate. Okay, so this is the first round. The second round, first number will have C. That's not true actually. So man, this is annoying. I think one thing that I maybe should have done or could still do is kind of write the brute force solution and then kind of generate, and then just to kind of help me visualize this a little bit more. I mean, I feel like I don't need it anymore, but I think that's what I could have done a little bit. But because here, if it's even number on a, this only matters on the, wait, does it? Maybe I need to take these two together and figure out what that means. Like take them in sets of twos. Six, 4, 4, and 8. Man, my math is not strong enough for this. Can I work myself backwards? Probably not. I think I think I'm on the right track. It's just that I don't know if I'm keeping track of enough states or even my states are correct. I think there's some kind of like you could probably reduce this to some kind of finite state automata for each bit. Okay, that's okay. Step back a second. Okay, so now you have 1, 2, 3, 4, 5, and you have 2, 4, 6, 8 essentially. Which is 1, 2, 3, 4. How do we keep track of what's next? We already ordered, so you have just 1 and 2 no matter which way you go, right? Is that right? Because you have 4 and 8. Well, in this case, you actually have 1, 2, 3, and 4. So you 2 and 4. So you have either 1 and 2 or 0 and 1. That's interesting, maybe. Because the other alternative is 1 and 3, and that divided by 2 is just 0 and 1. Is that interesting? I feel like this is similar to, but not really. Like I'm thinking about it in like that pyramid problem. But it's true that for every 2 adjacent entries, they only differ by the last bit. So there's something like that, but I think it's just my mind is not really up to. Okay, gotta stop making excuses. Okay. What do I do? So express it. Come on now. Okay, first of all, okay, so this is good maybe-ish. We'll figure out we need this later. And then the first, well, no, the first number will we'll have a 1 bit, so this actually it's not true. And then if the only thing that could flip is if the round number is odd. Oh, oops. I'm confusing myself a little bit. Okay, so if it's an odd row, we either flip it if n is odd. No, if n is odd, then we kill the first digit, so we don't flip it. So if it's even, then we flip it. Maybe. Oh, at least this one's really fast. So just like I was gonna make a salty comment about just like a lot of other things, but maybe it's a little too depressing. Because the first is 0, and then change to 0. This is no longer equal. No, I mean this is right, but is it? Right? Well, the end part is a little weird because there's 2 numbers left. The first digit is 0. Am I representing this right? Because you get rid of the first digit. There's some like weird thing that I need to do here. What does it mean? Right. This is a very annoying part. Only half an hour. Only half an hour. I wouldn't say that. That's not even right, is it? Because if it eliminates. I'm conflating a few things as well. Oh, yeah. That's, I think, always eliminate the first one. So if first is 0, then you keep the bit, right? Maybe I just try to overgeneralize it a little bit. Okay. Else, you don't keep the bit, so, okay. Now, odd rounds. The first is 0. No. Odd rounds, we check this for some reason. If it's odd, then we get rid of the first character or the first bit. The first bit is 0, then we get rid of the zeros, then we need 1, right? Else, if odd is even, what am I even saying? And the number of items is even, then we get rid of, sorry, this is, okay. So, odd items, then we get rid of the first one, and then first has to be okay. Else, if it's if they're even numbers, then you get rid of the second digit, so not first. And when do you update this? So here and here, maybe. Oh man, this is a mess. But like, I mean, I'm thinking only in terms of this input, so it doesn't mean anything to me. Yeah, not surprised that doesn't work for the other ones. It's unfortunate though. I was hoping. Not gonna take requests anymore. No, I'm just kidding. But these ones are always a little. I feel like these also in general. Someone has like a random like, oh yeah, this is how you think about a problem, and then the problem becomes way easier. And the coding is like 20 lines of code, so it's just like silly. But yeah, yeah, sometimes that's what it is. Sometimes even in real life, you're forced to do work on something that you don't necessarily agree with. So yeah. Also, maybe my n is not quite right because you don't always eliminate down. I think that's probably the other thing. Yeah. What's the answer for 10? Just very well. So you have 1 to 10. So you have 2, 6, 8, 10, and then you eliminate 2, 6, 10. So this is 4, 8, and then you eliminate 4. So it's just 8. Okay. What did I say? I had an insight. Oh, that 5 does not always go to 2, because in this case, okay, no, I lied. 5 does go to 2 in this case. And I need to use that. So it is still January. No, actually, no, that thought is actually what I just said was wrong, because 5 does always go to 2, because you always, because you start at the parity bit, you always remove the bigger of the half. So no, that's true. Okay. It's just which one? Zero is not even a number in it. Okay, we'll clean this one, and then 5, and then now we want to eliminate the first number, which has a 1 bit. So then you have 4 and 8. You have 2 numbers with 2 left. It is true that the first digit has a 1. Okay. I don't know. Because in theory, I need like one more check on the last bit, maybe. Because and there's no easy way to see which half it. My other thought is maybe there's a way I could re-index these in a way that I could figure it out. I guess people were saying something similar. I did not anticipate this farm going so long, because now I kind of want to use the bathroom. Like, I feel like I'm close. That the idea is similar-ish, but maybe my thing is more. Like, there are not that many other possible ways to do this, but man, but boy, am I struggling. Okay, let's think. What was my answers? Let me take a look real quick. I think I'm just not adding. Maybe I'm just not adding the last bit in a way, because I think I saw a couple of zeros on some power of 2 stuff. Okay, let's go down a bit. Okay, yeah. So maybe I'm close. I'm just missing like one more check. I don't know. Because I think I'm off by 8 in every one of these. So there's some like one more check. So I'm actually close. Okay, come on. So okay, so I'm close or closer, even though it's hard to believe, because I'm running less than a line of code a minute. And some of these are just declaration statements. But okay, but I'm close. So can I represent this in a slightly different way? Yeah, the other even thing's okay. I don't think there's different ways to handle it. If it's on even rows, you always do the first one. Maybe I could do better. we just keep track of the first number because it essentially, and then that will fix the offset. I'm looking at bit by bit, which is fun until it's not. So it's like an extra one, but I don't know how to send it. Or maybe I could just check it first. But I'll get the 6 wall, so and the 14 wall. No, the 14 I haven't done right. Then maybe this one will go down. I'll just add this first. Okay. Maybe another way to think about it is keeping track of the first number instead of the first bit. Would that work? Because essentially, you add the bit if you eliminate the first number. Is that good? And then, yeah. Okay, let me play around with that. I think I'm so close. But, like, doing some weird stuff. I'm missing by 1 bit. I think this is close, actually, to be honest. Okay. Let's see if I could actually salvage this a little bit. Okay, maybe I shouldn't print out all the things though. All right. But the urge is real, and what I need to use the restroom. Okay, but okay. So first, the first round, we made all of them. Okay, so we know that's 0. We know that's 0. We still know this is 0, but we have 1 number left. How do we know that? How do we? I think that's the one I have issues with now. If I just it's 9, we still have 1. We still eliminate the first. Okay, maybe I just need to think about it. Okay. Just say, okay, first number is equal to 1. So we eliminate the first one. Then first is equal to else if, well, else is it hardware if n is odd, then we do nothing. No. If n is odd, then we remove the first character. If it is even, then we do nothing. So okay. Oh no. If it's even, then no, yeah, okay. Maybe like maybe simple. maybe. Mm, maybe I should have done that in the first place. Kind of count the bits a little bit the other way. All right, let's see before I jinx myself. Mm, I mean, yay. I don't know how I feel about this. Uh, I think there's a couple of retro here. I think, I mean, that took 15 minutes. I think I got a little stuck on the bit counting a little bit. Um, but I think I didn't kind of say it explicitly, but in my mind, I think I shifted my mindset a little bit, and that was kind of the how I thought about it. I think, yeah, I got stuck on a bit, kind of like try to do something with counting bits, and I thought maybe oh, it's very close to a state machine type thing, and I think I could have probably still made it work. I just kind of maybe have to keep track of a thing. But I think one thing I realized was maybe we just keep track of the first number, since in because in some sense, the first number it's going to be it's actually similar to the pyramid problem that we had earlier, where at the end, if you have one number, then your first number is your answer, right? That's how I kind of eventually started to think about it. That's why I started one. Um, and then the second thing was thinking that for each row, the difference between adjacent elements starts at one, and then it doubles to two, and then four, and so forth, no matter what. Um, and then I asked myself, well, in that case, if you um, if you eliminate the first element, that means you just add it by 2 to the all power, or in this case, it's the number of round power, right? And that's it. And in that sense, that would have made the problem way easier. Hmm, and I kind of took well, way too long for a medium. I don't know if I could have done better. I think what I got stuck for a while. I think that's kind of I think sometimes that's a trap that well, I definitely get into. I don't know if others are similar, but in terms of just thinking about it for myself, I definitely get into a thing where I get into local minimas or local maximas, where like I'm like, oh, I'm so close. I just have to change this one thing maybe, but then I never found that one thing. Where I think if I alluded to this earlier, where if you get the right way of looking about it, it is a lot easier, and my second way of visualizing this was much cleaner. And I wish I kind of got into it, but I just didn't think about it enough. I was stuck in the that little that hill instead of going for the answer, and that took a while. Um, I mean, I would say maybe on an interview if I get stuck like that, probably probably an interviewer would probably nudge me a little bit in the right way, and hopefully that in that case it doesn't take another hour. But this is so I don't know how to feel about this one. So maybe I just don't have a good opinion about this. It's a little tricky to think about, but if you have the right kind of mindset, it's easy. But I don't know if I could build a good like, and this feels like one of those problems, to be frank, where like I didn't see it today. I see it tomorrow, and I just kind of like, oh yeah, this is obvious. But like, and that's what I mean by a little bit of like, I don't know, like it's a little what are those like a brain teaser y thing where like, eh, uh, I don't know, but yeah. So I mean, you would not see me give these kind of interview bombs, but I don't know if I would expect to see this. I feel like if I see this, then well, then I rolled the dice. I mean, I've already rolled the dice, and I'll see how it goes. I don't know if I would have definitely would struggle a little bit and don't have that much confidence. And as I predicted, the final code is like 10 lines of code. It's just way tricky 10 lines of code. Um, but to be frank, knowing the answer now, it's not even that tricky. It's just I don't know. I feel like maybe I don't know if this is one of those cases where like like in a weird way because I have a lot of tools in my tool shed, if you will, that I was trying to do them, like doing bitwise things. Maybe I was trying a little too hard there, but as soon as I kind of got the right idea, and maybe like a someone whom is not as kind of in the weeds in the lead code, maybe they could have gotten it easier because it's more obvious to them the right approach. Because in some way it is like I mean, and like there's no heavy machinery in this. It's just understanding binary numbers, which I think you can figure out. I mean, I don't know. Maybe but that's definitely the easier part. So I don't know if I would expect to see this, but if I do, it is what it is. But I don't like this as a file for me anyway, and maybe that's just bias. But yeah, I could explain it again and try. But I think so. Actually, my railroad names are well. I mean, this could be wrong, but and it's more straightforward. Is that so? I think so. If you look at the rounds here an example, um, so each adjacent number is always going to be just 2 to the I for some power I, right? I think that's. I mean, I think that's we've been people have been talking about it. I think in the chat. So I think that part is it's understandable. Um, though I think there's a little bit slight framing in that we always eliminate where the delta is 2 to the I plus 1. But even before that, for each row, like in the first row, the delta is 1. For the second row, the delta is 2. The third row, the delta is 4. And the last row, the delta, well, it's just there's only one element, right? So that, powers of 2. So in that case, you just keep in track of the first number, right? And then for each, you simulate whether you remove the first number, uh, and that's it, right? In a weird way, and then just follow through what that means, which means well, for every alternating steps where you go left to right, or in their terminology, left to right, um, you always eliminate the first number, right? Uh, and when you always eliminate the first number, then you just add the next. You add the delta of that row, which in this case on the first row is just plus 1, right? And well, if you don't eliminate the first row, if on even rows or the rows where you look back, you don't eliminate the first row, the first element. Sorry, I keep saying it wrong. But on that row, you don't eliminate the first element, then you just keep the same element. So you don't. There's no adding here. Basically, it's when these things are not true. Um, but yeah, yeah. So then you just keep the first element because in this case, in the next row, the first element is still 2. Uh, and then in the next row, you eliminate the first row again. Or I keep saying row, sorry. You eliminate the first element again. So you know that the delta are always going to be 4 in this row. So you add 4 to it. So you have 6 left. And now you have only one element. So so you return it. Is that okay? I mean, it's such a like it's such a like once someone show you the thing, it's like I feel like it's so much easier. And even looking at the code is not clear, to be honest. Like you have to like have that kind of. But I think I would say if you want to practice this a little bit or like kind of think about it, just think about what it means to just keep track of the first element, and then once you and you have to think through it a little bit. But let's just say you know, start with 1 because that's the entire sequence. Keep track of the first element of that row, and then follow through what that implies. Um, and like, what happens when you eliminate the first element? Well, it's just the next element, and then there's some state around that. I think that's a. I hope I explained it okay. Because let's say you have 2, 4, 6, 8, 10, which is the only other possibility for like 10. Then you would eliminate the first number, and you know that the next number it's 4. Then you keep 4, and 4 is your first big number or your next first number. That makes